Okay, good evening to every one of us. We are welcome to our first lightning session for the year. Um, we've I hope we all enjoy the early holidays, and I know some of us did not stop looking at our computer. We're still typing codes and debugging. But I hope we enjoyed our holiday, and we are welcome once again to today's lightning talks. So, as you can see on our screen, you can see the topic displayed: maintaining high concurrency while safely processing background jobs in distributed Java applications. So, I hope we all have our notes and we are ready to learn from our senior engineer, Mr. Amos. He has been a very key person in our community. So, without further introduction, so we don't take much of our time, I'll give him the floor. And we're all welcome to this new year once again. Mr. Amos.
All right, Samuel, thank you. Um, Good evening, everybody, and I'm happy to be here. So, my name is Amos, and I'm part of this community. Um, so, I'll be taking us on this topic. I hope I'm able to um, say one or two things that will help us in our daily um, life, maybe in our job. I'm just happy to be here. So I'll try to make sure that we keep within the time, and but feel free to raise up your hand and ask questions in the course of this discussion. So I think I can continue. So let me move to the next slide. But just to provide a context, please, can you hear me? Let me confirm that. Okay, excellent. Thank you. Thank you. All right. So, maintaining high concurrency while safely processing background jobs in distributed Java application. So, let's look at what is background jobs, right? So, if you see my second slide, let me see. Okay, second slide. It's just about me. You can connect with me on LinkedIn. Um, so this is the content we are going to go through. So what are we optimizing? So I'll provide a bit of context. So background jobs are these jobs that you usually write, and while the application is running, while the APIs are running, you have a background job that do some certain things. For example, you want to schedule restock of items. Maybe you have items and then you have a threshold that once the inventory is lower than a certain threshold, then the application should automatically restock. So some of this kind of job or some of this kind of tasks are actually done in the background because they are clear. You don't need somebody to click an API or a button for this kind of tasks to be done. So you handle this using background jobs. So, but writing background jobs can be very, uh, can have a lot of issues. And those issues are the kind of things that we wish to discuss here and see how best you can be able to do these tasks. There are a lot of opportunities for these tasks in your organization or in your daily job. So we look at how best this can be done. So this is actually the topic. So the domain of our discussion is around the inventory stocking, um, um, around inventory management, how you are able to restock stuff automatically. So I'll be walking us through. We'll start with a naive implementation of this use case, and then we'll discuss all the problems associated with that. And then gradually we are going to move to a better solution. So let's see how that goes. So the next slide, what are we actually optimizing? So we are looking at concurrency because user-facing latency must stay stable under load. We are looking at safety so that jobs must not be lost or duplicated. So in the course of doing this, we don't want any loss of data. We don't want mutation. And so how can we do this? Then we also want it to be operational operability. Failures must be observable, and we should be able to recover in case there is anything. So around these three pillars, you have concurrency, safety, and operability. So this is where what we are going to optimize. This is what we are expecting. This should be our standard in doing this. And so let's see how we can be able to do that. So I have a slide here. I have a code. For example, this code is basically, I have a cron job. So in Java, this is how you do a cron job, right? So you have this at schedule annotation. You set your fixed delay, 60 seconds. Yeah, that's basically 1 minute. And then you are trying to, so if you are a junior developer and you have these tasks, you have an inventory. These are a list of products, and these products, they have, by the way, later maybe I can switch to IntelliJ and show you guys how this is working. And I also provide a link on the Git repository in case you can check it out and see how we are able to move to the final solution. But basically, let me provide context to this code. So you have a list of inventory products, basically. And this product, they have a threshold. And so basically, when you have like less than 50, you should be able to restock automatically. So this is what this code is doing, and the delay is after 1 minute. Then this cron job is going to run and check if we have low stock. Then if we have low stock, then we are going to get the list of all the low stock. You cannot see my screen? Someone is saying cannot see my screen. I should check my
Hello, I
net.
think we can see your screen.
Okay. Okay, so you guys can see my screen, right? Oh, okay. So kindly check your network, please. And so what we are doing here is you check if you have low stock. So you go through the list of all the low stock, and then you generate a quotation, and then you use that quotation to restock, basically. So you save into restock order, and you update. You can see after you restock, then you are going to update the quantity in product. So you are basically interacting with three entities here. But to keep things simple, the supply code, I just simulate it here. But this can also be another network call, right? Or maybe a call to the database. So the supply client there is simulated in this case. So we are not actually making a database call or maybe a network call. So, but in real life scenario, maybe in your organization, the supply client that is there, that is for the code, can also be a network call. So you can see what is happening here. You are interacting with about three entities, you are mutating, and then you are trying to loop through and you are trying to solve. So now, this is the question. If you see this line of code as a senior developer, or maybe you are doing code review, now what do you think is wrong with this approach? What is wrong with this? This looks, at first glance, maybe you can say this is okay, right? This looks good. This can work. Of course, if you run this code, it's going to do what you, maybe for the first try, it's going to be working, right? It's going to work. So, but what is wrong with this naive implementation? So this is what we are going to discuss. Now, the first thing for me, uh, I don't know, is this normally interactive, or I can just speak all through myself and then I will take questions? I
So you can speak all through. Then if there is a question, we'll take it at the end of the session.
section, okay, that's fine. So, but can people respond? Like, for example, can somebody, can
Yes,
I?
yes, yes, yes.
Oh, perfect. Yeah, so that's what I want. I want a bit of, let it be interactive, right? So um I'm just asking, what do you think is wrong with this code right now? Or although the slide is saying that, but maybe can one or two people just tell me what they think is wrong with this approach at the point? Just one person, right? Or does this look good? Okay. It looks like we are not talking, right? Okay, so a lot of things are wrong. For me, one, you can see the SQL code that is generated there. Select all from product where quantity is less than 100, order by quantity, I think. Um, so it means that we are going to select all the products that have um, quantity less than 100. Okay, so at least we have our low stock. That's what we want. And this is the my SQL query that is generated to insert into the restock order. And then finally, we are doing update on the product quantity. So basically, we are doing three things in this code here. Now, what if this application crash at this point? Maybe somewhere here. And you see my cursor, right? Okay, so hold on. So if there is everything wrong here, so the first thing is, what happens if this application crash at this point where I have this crash here, right? So we know, right, what's going to happen. We are at this point, maybe we can restock, but then we are not able to update the quantity in product. So if you, after 1 minute, this cron job want to run again, then it's going to still fetch low stock and try to restock again. So you are having inconsistency in the state. So this is wrong. That's one of the problem. I can see here. There are a lot, but now top priority for us here at this point is how can we overcome this? All right. So that will take us to the next slide, and then if you try to amplification of this job, then you start having a lot of issues, inconsistency in the state. So this is wrong. So how do we solve this? There is no transaction boundary at this point. So what can we do? How can we improve this? You know. So that will take us to the next slide. But I guess we are already thinking that okay, maybe some of us are already guessing the solution, I guess. So you look out for this. So the next slide, we try to fix this. How do we do it? A transactional annotation, right? To create boundary around this. Yeah. So now I will use this opportunity to discuss some, IC property, right? So a transaction help us to achieve what? I put all this annotation in details here because a lot of us have been using our transaction. But when we put this our transaction, then it's fine because we stick to the default, right? So first of all, at a transactional annotation, we'll have propagation level. By default, if you are using Spring Boot by default and you did not specify the isolation level, what do you normally have? Do you know? Well, is this one that is here. That's the default, propagation dot required. That's what you have. Most of the time is enough. But you need to know propagational level to decide because sometimes your use case does not just conform with this propagation dot required. So let's read about propagation level. There is propagation dot required dot new. There are other ones. You can check it out. But in this context, it's enough. At required means if there is a transaction going on, then you use it. Otherwise, you create your own, right? So you wrap this whole method into one transaction. So this gives us all or nothing. So atomicity is restored. It means that if there was a crash at any point in this method, then it's going to roll back. So we are able to solve that. All right. So all operations succeed or fail, no partial update. So we have solved that now. Consistency, it means that the database moves from one valid state to another. We are able to achieve that. Then isolation level. So if you are using Postgres, in this case, I was using Postgres. And also I want to point out the importance of isolation. These are the things we need to understand. Isolation level are very important when it comes to database locking, because most of the time, you need to do locking a database, concurrency and controls. So isolation levels is what helps you to do this. So it prevents reading uncommitted changes, but that's not there are different isolation levels, right? We have about 3 of them that I can remember, you know. So we need to also understand isolation level, but I'll discuss more isolation level in the next as we continue. But you need to know that there are also different isolation level, but by default, if you are using Postgres, then the default isolation level you can have is this read committed. So this one basically help prevent reading uncommitted changes from other transaction. So if you have two parallel transactions happening at the same time, it will ensure that one transaction has committed its changes before it can read. So by default, if you don't have any settings on your Postgres, by default, this is what you have. You can check that out as well. Just go to your Postgres, get a command from ChatGTP. How do I check my default isolation level? You will discover that this is what you have. And sometimes you will need to change this depending on your use case. So if you are doing pessimistic locking, for example, you have a very critical change, and maybe you don't want concurrency, stuff like that. You can change this. But this isolation level basically provide a balance between concurrency and uh, concurrency as well. So it doesn't give you high concurrency, but it also doesn't give you low concurrency. So just a balance. You change this based on it. But I'll talk more on isolation level as we continue. So now we have fixed our code and looks good. All right. So um, looks okay. But then let's see what other things that can come up. So now, what if at this point in time, our application, what happens now when this application now become large? Maybe the database has grown to millions. Will this same code also be useful here? So how do you scale that code? This looks good for small data in my opinion. But then what happens if this database we have a lot of customers, we have a lot of inventories coming in, we are expanding our stores, then this becomes very slow, in my opinion, because we are selecting all, right? So it will get to a point where your list of low stock will be pulling like 10,000 records, and then you are looping through to be able to, process this. So this becomes a solution that is not scalable. So how can we optimize for scalability? So just to point out what can possibly be issues here. So when this becomes, when your enqueue rate exceed processing rate, queues fill up, then worker throughput limits, you will discover that the CPU will start getting, you start, if you are doing monitoring, this is the time you start seeing high peak in your memory consumption. And you'll be wondering what is happening. So the solution that was working fine suddenly become bad because there is increase in volume of items in the database. All right. So how can we scale this up? Let's go to the next slide. I hope we understand the importance of these things, right? So far, is it making sense to us, right? All right, thank you. Okay, so let's see how we can scale this up, right? How can we do this? Now, so many ways you can look at it, but for me, very straightforward solution. I would like to reduce the number of record that I fetch in the database. So instead of selecting all, I say find top 50 by quantity. So I just get 50 rows per each processing, right? So at this point, this looks good. It means I can only fetch 50 records. So when I fetch 50 records, I can process them, and then that's okay. a bit of scale. It's scalable at this point. At least I will have shorter um, records pulled to my memory and then I process. But this single decision that we have decided to make now has created a lot of issues for us. Remember, we have at transactional notation over there wrapped into this. But even before we go to that, it means that we are running this cron job every 1 minute. So if I have 10,000 records, it means I can only process 50 in that 1 minute. Then I will wait again. After 1 minute, I will do that. So it doesn't make sense, right? It means I have to wait for 60 minutes before next run. So what am I doing? I'm wasting time. Because 50 records can end quickly. I can process 50 records in a millisecond. But then I have to wait for another 1 minute. These are problems with cron jobs. And we have to do it right. Okay? So I am selecting only 100 records, where less than 10. Yeah, so 10 in this case, that was the threshold, right? So we are getting 50 records only, as you can see from the fixed side, limit side. Now, but loops complete quickly, in 5 to 10 seconds, we are done. And then we are now waiting. My junior developer can be so proud that he has done a very perfect work here, okay? And looks right in my, if I look at it, it looks right, okay? But this is where we need to pay attention. In production, we'll start seeing issue here. So how can we improve this? Are we understanding these problems, right, guys? Excellent. All right, so how can we scale this? Very simple. I will show you guys on the next slide, okay? So in the next slide, look at what we have done. I put Y true. So you guys are like data structure and algorithm. This is a perfect case of doing edge cases, right? You know, I take from brute force approach, I optimize. This is what we are doing, guys. We are optimizing. So see what I've done. I say Y true, then fetch this, all right? And then I am checking, is the list empty? If it is empty, then I break out from this loop. I don't need to process. But what this means now is that I can process, if I have 50 and I start in 1 minute, then I'll make sure I process all. If I have 10,000 records, I can process all 10,000 records before this job will stop, because I have my Y true. So only when it's now empty, I break out, okay? This looks good. Does that make sense to us, right? Yeah, it makes sense. But this gives us a this decision that we are smart, right? This looks good. Very smart guy. You are a good developer. Excellent. But what is the problem here now? There is a problem. Look at, remember this transactional notation is over there, wrapping this. So if you have 10,000 record now, it means that you will have, how many of us know first level cache? Entity management. Remember, we are using Hibernate here. Do we know entity, first level cache? Do we know first level catch? We know, right? Okay, let me just explain. First level catch, it means that each time you call a database, you say fetch all, for example, fetch one, it doesn't matter. The entity manager is going to catch that object for you and keep it. So in this case, we have 3 objects. So each fetch, we are going to have 3 of these in an entity managed in a catch. We have a cycle for that object because we are mutating. So it's going to be there. And then we put a transaction annotation on top. It means it's going to wait for this number of time we are processing. So we have a loop here. Looping for 10,000 times, we are going to have large entity management. If you check your memory at this point, you will see a lot of entities there waiting. So you have a long running transactions with a lot of entities being cached at first level. Because remember, you are trying to modify them, so they will remain there. This is by default, this is what Hibernate will give you. Except you are using Spring Data JPA, then you Spring Data JDBC. Then you can manage these things yourself, but then let's assume we are using Hibernate. So long-running transactions, this will lead to a lot of issue with your connection pool. First level catch. Please guys, check this thing now. Check entity management lifecycle. You will see these issues. All right. Now, at this point, looks good, but this is what we get. So how can we fix this? Does this make sense? So this is how we can fix. For me, I have not seen any other way, but I know one thing. There is a way you can just create, and there are different ways to do this at transaction annotation. Perhaps if you don't know, today you will know. You can write a small code in a transaction, but you can do that by removing the annotation, the transactional annotation, and bringing in what we call I can see that the code does not show us the import for that. So let me show you guys. Let me but there is this transaction management template, right? That's what we are using here to do this. But just look at the code. So I will show us the code. You can check this code out, right? Later I'll share the link. So we have what is called Platform Transaction Manager. This is Platform Transaction Manager. So the naming was misleading. So that's why I'm trying. It's not Transaction Manager itself. It's Platform Transaction Manager. And you should know that for each before you have a transaction manager, you always have a platform transaction manager. Is that correct? If you know how to set, you can create your own transaction. And the candidate for that is platform transaction manager. You are going to use it to create your transaction manager, right? So you can use platform transaction manager to be able to create rapid transaction around some settings code. And that's what we have done. So in this case, I use a transaction platform transaction manager to create a section that manage only this execution of code here, this cron job. So what this means is that if I select 50 records, then those 50 records are going to be wrapped within one single transaction. And after that is discarded, and then we can fetch again. Guys, this is how to do it. So I remove the transaction annotation on top from there. Then I put it inside, wrapping around this code. So what does this give us? Short transactions. Shorter transaction. 50, only process 50. Then garbage collection will happen because the entity level catch will be discarded before another one. Catch is cleared. Your connection pool is also happy. Are we learning something, guys? All right, Bright, your hand is up, right?
Hi, good evening. Sorry, from my end, I have like a quick, question because I'm kind of confused at some points, right? I don't know if you can take questions.
Okay.
Okay, so I'm looking at your cron job. You have a fees delay for like I would say is a minute fees delay, right?
Yeah.
Then you are wrapping your logic in a while loop, which is the while true, which will kind of run indefinitely, right? So you have your code inside the while loop, which is going to run actually indefinitely, and you also have a cron job that will keep on calling this indefinite job every 1 minute. So I'm trying to understand the thought process behind that. Like,
Okay.
what problem is it actually solving?
Excellent question. All right. So one, the cron job is not running indefinitely, right? So let me point you out to the code. You can see at this point, I say Y true. Y has more to process. I get the low stock. And then I check if this low stock at any point will be empty, okay? Then we return true. So once we return true, this guy is going to terminate. Because remember, this guy, the platform transaction manager returns, when it executes this whole code, it's going to return the value true or false. So once this value becomes true or false, it's going to terminate the loop. So this is not running indefinitely. Now the thought process here is simple. So let's assume because you have a cron job that delays run 1 minute at a time. It delays for 1 minute, then it runs. So I have explained in the next slide that what happens, let's assume I have 10,000 records that are low stock and I want to process them. But we are selecting only 50 per each delay and we are processing. So if we are selecting only 50, because we want to scale, we don't want to put too much record and process at the same time, we are selecting only 50. Now, if I don't find a way to continue to process multiple of those 50 within this, it means that I have to wait for each 1 minute to process only 50 records. That's not a good process, right? So because it's a cron job, I don't care. What I want this cron job to do is, if I process all my low stock, restock them, and do it fast. So if I have 10,000 records, then I will be able to process all that 10,000 before I do another delay reschedule. So that's the thought process. I don't know if I've answered your question.
Okay, so that means that this products repository dot find low stock is going to going to fetch the whole 10,000 record and process them inside the while loop, right? Is that
Yes,
it?
it will fetch 10, 10, 10, 50 batch. That is, it will fetch 50 per time and process, but make sure it process all the 10,000 per each core of this, because this is similar like clicking an API, right? But just that you are delaying and rescheduling after 1 minute. Now, the implication of not doing this while loop, it means that you will only be processing 50. Then you will wait. Then you process 50 again. You will wait. Then you process 50. But with the while loop, if there are 10,000, you process all the 10,000 before you do another call of it. So that's just what we are trying to solve.
Okay. All right.
Yeah,
All right. Thanks.
makes sense. So Mark, go ahead. All right.
Okay, thank you, Amos.
You're welcome.
So far, this is clear. My question is this. You've been giving your example with 10,000 records, and the delay is 60 seconds. Is there not a case where the records that needs to be restocked are, say, 6 million, and it happens to be that the process is not able to finish restocking and then 1 minute passes? Is that not a possibility? Because you've been giving your example with 10,000 records. What if it is more? If it is times 10,000 times maybe 1,000 records, right? So
Yeah.
what happens at that case? And the time it took to process, say, 6 million records exceeds 60 seconds.
Yeah, so that's a good question, right? So even at this point, right? Even at this point, what is happening here is we are not saying that this process is going to happen within 1 minute. No, that's not what the code is doing. Yeah, what we are saying is the code only delays for 1 minute and then it calls itself, right? So, but when it starts processing, if there are 1 million records in here, with the while loop we have put here, it's going to try to process all the 1 million records before it will call, delay 1 minute more, and then call. So that's already handled, right? Did I answer your question?
Yes, thank you.
Yeah, so that's already handled. But you will know, and the next slide I'll try to see how, because now if you have 1 million records and it's only this guy that is trying to process that, then it's also not good enough, right? So let's see how we can scale that up, and we'll see in the next slide. But right now, as a single cron job, this guy is able to do it. He's able to do it well. All right. So okay, go ahead. You can go ahead.
Okay, please, could you clarify what the platform transaction manager does?
I followed the mic. Can you hear me?
Yeah, go ahead.
Can anyone hear me? Please, the link will be ending in the next 4 minutes. So there's a link that dropped on the chat. Let's join the link to continue. We can
Okay.
continue from there with the question mark. Apology.
All
All
right.
right.
Thank you.
All right. I will explain there. So should we can drop and join the other side, right?
Yes, please.
Okay.
Thank you. You cannot join the new link. Thank
Glory, where can I see this link?
you. Let me send it to you on WhatsApp directly.
Yeah, send this other WhatsApp that I share with you.
The new link. All right.
Yeah.
Okay. Simon, please, I've sent it to your WhatsApp.
Okay, I'll join on.
All right.
So let me end this one.
Please, if you're here and you can help me, kindly check in the chat box. You see a link created. Then you join the meeting on that link. We are commencing like to continue on that link, please. If you can hear me, please, check the chat box, then join the new link. Shama, if you can hear me, this meeting will be ending in the next. Shama and Donka, please join the new link.